So before we go on to talk about angles today, we're going to finish up some vocabulary because I want to make sure that you have the right amount of vocabulary in there. Okay, so first thing is a line segment. A line segment, which we did not talk about really yesterday, is just a section of a line. So a section of a line that can be measured. It's a section of a line that can be measured. We name it with two endpoints or with two capital letters. What do you mean? Okay, so let's draw an example of what this looks like. So we're going to draw a part of a line that has two endpoints. Okay, that's what a line segment is. And we'll call this point A over here and point B over here. So the way we name this, remember a line is two capital letters with that line symbol above it. Okay, so line segment is two capital letters, but it has a line segment above it, just like that, with no arrows on the ends. You don't need to put two little dots on the ends of the line, just a segment, okay? But that means something different than the big arrows, the line with the arrows, okay? We talked about yesterday our distance formula is our formula that allows us to find the measure of a segment. Allows us to find the measure of a segment. And let's go ahead and write our distance formula over there in the big space. Remember, these x1 and x2 should be lower. They're not exponents, they're subscripts. Okay, what about congruent segments? Does anybody know what congruent segments are? We didn't really talk about them. John?
Segments that are the same length.
Segments that are the same length. So congruent means the same measure. So congruent segments are segments that have the same measure. So segments that have the same measure. Okay, to mark things to be congruent, we mark with hash marks. Remember that yesterday? We mark with hash marks. So, for example, if I have this segment here, we'll call this one PQ. And I have XY over here. If these are the same, I'm going to mark them with the hash mark. And then the way that we write that things are congruent, I would say segment PQ, we just learned how to write that, is congruent. This is the symbol for congruent, an equal sign with a squiggly on top. That means congruent. PQ is congruent to XY. So maybe over here in the notes part you put congruent sign is this equal sign with a squiggly. That means congruent. Okay, so the other thing I want to show you too, look at this example up here on the board. If I draw two hash marks and two hash marks, it means the same thing. The the segments that have a matching number of hash marks are the same, right? So if one of them had 1 and the other one had 2, they would not be the same, all right? Okay, I think the next one is segment bisector. Flip it over, or else it's midpoint. Which one is it? Midpoint. Okay, so we learned midpoint. Formula is the middle of a segment, right? That one's pretty hard. Okay, so midpoint formula we use to find the midpoint. Okay, so used to find next page, do you have it? No. Okay. Used to find the coordinates. Let's put that in there because sometimes we forget that it's an XY pair. Used to find the coordinates, and we're going to put x comma y. So we remember it's in the middle of something. So it's an x and y pair. Used to find coordinates of the midpoint. And then we have our formula. Remember, we add our x's together and divide by 2, and then we add our y's together and divide by 2. And we finish with an xy point. Okay, what about a segment bisector? What does the word bisect mean? Don't, what?
Take apart.
Take it apart, right? Bisect, how many is bi? 2. So 2 sections. So a segment bisector cuts. So our word is a segment bisector cuts a segment into 2 congruent parts. And we're going to use our congruent symbol there. A segment bisector cuts a segment into 2 congruent parts. So I'm going to go ahead and draw a line segment over here, CD. And if I say line M is a segment bisector, then that means that line M has just cut this piece to be the same as this piece. And we'll say that it intersects at X. So line M is the bisector of CD. And if it's bisected, you need to mark congruent. All right, so maybe make yourself a note there. A segment bisector, we need to make sure that we mark, because they're not always going to do it for you, mark congruent in your diagram with the hash marks. Okay, let's go ahead and go to the angles now. We're going to skip and go to the angles section. So this is topic, we're going to say 1.3 angles and relationships. So 1.3 angles and relationships. There you go. Yep. Today is the 13th, and we have 28 days of class left, in case you were wondering. Now, some of your teachers maybe said like 26, but it depends on if you're taking the ECA or not, which we are not taking the ECA in this class. Geometry does not have an ECA, so there are 28 days left. Okay? All right, here we go. I'm going to teach you about angles as if you've never heard about what an angle is before. Okay, so if you have, that's fine, but we're going to go back to the basics of what an angle is. For some reason, angles sometimes are hard for students to grasp about how to name them and where exactly is an angle and what an angle is. Okay, so I'm going to do my best as we go through this to make sure I don't leave you in the dust. Okay? So an angle is formed by two rays. R-A-Y-S. And a ray is a part of a line that has an endpoint and then an arrow on the end. That's a ray. So an angle is formed by two rays with a common endpoint. That common endpoint is called the vertex. Now, if you were in Algebra 2 with me, vertex sounds familiar, or else it should. Pretend like it does, please. It's the starting point. So if we look at this diagram over here, do you see that B is the vertex in this example? Okay, so B is the vertex. And I have this ray here, and I have this ray here. So the space that they create together, the two of them, the space in between is called the angle. This piece right here is called an angle. This section in here, we are creating an angle. Okay? So the rays are called the sides. The rays are called the sides of the angle. We name an angle using 3 letters, always. And the middle letter must always represent the vertex. I cannot stress this enough. The middle letter must always represent the vertex. So if we look at this angle over here, we could name this angle by saying, this is angle, this is how I tell students to do it. I start at A, go down to the vertex, and then go out to C. Right? Start on one of the edges, one of the points on the outsides, A or C, go into the vertex, and then back out every single time. Okay? So this would be angle ABC. There's our angle symbol, by the way. Angle ABC. Or you could name this angle CBA. But if you notice, which letter is in the middle both times? Why is that? Because it's the vertex. Weird, I know. But B always needs to be in the middle. If it's not in the middle, then you're talking about a completely different angle. If I'm asking you to find out the measure or how much it is, we say that the measure of the angle is 60 degrees. You guys see how there's that 60 there? Okay? But you notice that there's a little M next to it. That means measure. That's what that M means. It just means the measure of the angle. Now, if you notice, they don't use a little hash mark on their angle. They just do their angle like this. They don't draw that little arc thing. I need you to draw that arc thing because some of your L's are going to look like angles and some of your angles are going to look like L's. And so to just erase any confusion, I want you to put the little arc thing on your angle symbol, okay? All right. Moving on. Types of angles that we have. Types of angles that we have. If we have an angle that is less than 90 degrees, you guys have heard of 90-degree angles, whether or not you know what they look like. You have heard that some angles are 90 degrees. Okay, so which one of these in these pictures is a 90-degree angle? Anyone know? Ashley? The third one. What gave it away? It's straight up and straight across, makes a little square. It's perfect. This is called a right angle, where the measure of the angle is equal to 90 degrees. That's what that little box means. That little box that's there means that it's 90 degrees. You can never assume that it's 90 degrees unless you see the box. Okay? if you look at the first angle here, do you notice that this one is smaller than 90? This angle in here is smaller, right? Because a 90-degree angle would be like this. So this one's smaller, and this is called, anyone know? Acute. And I like to say like this, a cute little angle. Just a cute little guy. But it's actually acute. I have to tell you, long story short, I was online dating someone. Anyway, and I told him I was a math teacher, and he said, well, aren't you acute? And I said, I think this is done. I can't do this anymore. Okay, anyway. Okay, so any angle that's acute has a measure of the angle is less than 90. Less than 90. Okay? And so then the third type is if it's greater than 90, this one is called obtuse. Okay, so the measure of the angle is greater than 90 degrees. Now, if you forget your degree symbol, I'm not going to count it off, but it is degrees. All right, let's look at example 1. It says, name the vertex of the angle. Over here in example 1. Someone raise your hand and tell me what the vertex is. Shelly? K. Excellent. Instead of putting the word point, let's just draw a point. So point K. Name the sides of the angle. Who wants to give me a side? Elvis?
Point L.
Is the point by itself a side?
Oh, never mind.
We would go ahead. Try it again.
Be like line KL.
KL. Good. Now, I would say, remember we just learned that this is called a ray, right? We just talked about that's called a ray. So we're actually going to say ray KL. So we're going to start with KL. Our arrow is going to be over the top of the L because the L is what continues to go on forever. You guys see that? Okay, good, Elvis. So then if that side's KL, what's the other side? Katie? KJ. And again, the arrow is going over the J because that's the side that's going off forever. All right, 3 ways to name an angle. Who wants to name this angle for me? This angle right here. Someone I haven't heard from today, or else I'll start calling on you. Chris.
Angle JKL.
Angle JKL. Notice that Chris kept the K in the middle. Angle JKL. Excellent. Oh, I have 2 Chris's. I have to be careful about this. Okay. What's another way to name this angle? Monica? LKJ. And then the third one is a little bit different. We didn't really talk about it. Chris Stoller, what do you have there?
Angle 1.
Ooh, angle 1. There's no 1 anywhere, is there?
Example 1.
One of the things that you can do that I don't like to do very often, but sometimes there's going to be a problem where you have like 8 angles and you're trying to like figure out and they're all the same kinds of letters. So you are allowed to just write number 1 in here in the middle of the angle. And then you are now allowed to call this angle 1. But if you tell me that it's angle 1 and you don't have a 1 anywhere in your diagram, it's wrong. Okay, so if you're going to call it angle 1, you need to write angle 1 in the angle that you're talking about. Okay? James, did you have a question?
No.
Okay. All right, why don't you try example 2 on your own? Oh, that's a long example. I didn't realize it was that long. Okay, try like the first 3 letters. Sorry. Oh my gosh. All right. Brave people in my class. You guys are all courageous and you're confident. So, that being said, Carla, letter A. What is the vertex of angle T? I mean angle 2.
TU.
Okay, so you're giving me the angle, which is another way to name it. I would agree with you. But if it's just asking for the vertex, it's just this point, right? Good, just T. Okay, it just wanted the vertex, the starting point. Okay, name the sides of angle 4. So we're talking about angle 4. Okay, so angle 4 is over here. This is angle 4, right? So, Shelley, what's one side? TZ. So, ray TZ, she said. Okay, ray TZ would work.
Why is it ray TZ? Do you got to count the T as it?
T is the starting point, right, where that ray starts,
Okay.
right, and then goes to Z. Brian, what's the other one? Now, you have to start with T, right, because W is what goes on forever. Okay, so ray TW. Good. Name another name for angle 3, Lexi. Another name for angle 3. This angle here. Hey, thank you, Lexi. Go ahead. Okay, Lexi, look. Which one is the middle? T is the middle, right? So I have to start on the outside. So what's one of the ones on the outsides? What'd you say? Okay, TZ. So if we start out here with Z, I can go from Z to T and then to U. Okay? So we could say angle ZTU. Or UTZ, which is what Brian said in the first time. Okay. Write another name for angle 1. Donald Schrock. Angle 1. Angle YTX. Perfect. So you started at the Y, went to the T, and now to X. Angle YTX. Excellent. Okay, name the sides of angle 5. Sharmini, what's one of the sides of angle 5? Ray TY. Excellent. Ray TY. And Shane, what's the other angle? I'm sorry, the other side.
TW.
Perfect. TW. Ray TW. Make sure you put your ray symbol above it. Okay, Braxton, it says classify angle YTW. So angle YTW is this angle here. Is that an obtuse, acute, or right, Braxton? What'd you say? Right angle. What gave it away? The box. Good. So this is a right angle. Okay, Amanda, angle YTU. So from Y to T to U is this angle here. Would you say that's acute, right, or obtuse?
Obtuse.
Perfect, obtuse. It's bigger than 90. Okay, angle XTU. Natasha, angle XTU. Acute. XTU. Good. Is acute. And last one, Kyle, angle WTU.
Obtuse.
Obtuse. Good. Any questions on that, guys? All right. Speak now. Forever hold your peace. No? Okay. Let's turn to the next page. So we're going to talk about some relationships with some angles. Okay, so some relationships with angles. Okay, so we have different types of angles that we're going to need to look at, and these will carry on for the rest of your geometry career. So starting now until 28 days from here, June 1st, you will deal with all of these types of angles. So it's really important to make sure you know what these angles are, okay? So the first one, we're going to talk about vertical angles. So all 5 of these angles are going to be vocabulary words that you need to know, okay? They're on the front, I believe. So vertical angles are 2 angles that are across from each other on intersecting lines, and they are always congruent. So let's draw an example. I have 2 lines that are intersecting. 2 lines that are intersecting. Vertical angles are across from each other. Okay, so they make an X. So if I'm looking at this example, I would say this angle over here and this angle over here are vertical angles. You see how they're making that X together? Sure. Okay. Also, do you agree that the top and the bottom are across from each other? Okay. So we're going to put 2 arcs here and 2 arcs here. The reason for that is because the 2 arcs means that those 2 angles go together. And we know that these angles are congruent. So if I told you that this one over here was 70, what else is 70? The other side, right? This side over here is 70. Okay? Those are vertical angles. Adjacent angles. Adjacent angles are 2 angles that are next to each other. So if I drew something like this, then this angle and this angle would be called adjacent. Now they don't look like they're the same size, so I'm not putting the same number of arcs, right? Because the same number of arcs means that they're congruent. They're not congruent, so I'm putting different number of arcs. They're just adjacent, they're just beside each other. Okay, the next kind is called complementary. Any 2 angles who add up to make 90 degrees. So if I have a right angle here, okay, and I have 2 angles that are beside each other. If I tell you that this angle is 60 degrees, how much does that little one have to be? 30, right? Because 60 plus 30 makes 90. Did you say no way? The little one over on the other side, the left side. So we have this one over here and this one, okay? All right. Yeah?
Okay, I have a question back on the adjacent angle.
Sure.
Does it matter which one you put more angles on? Or?
No, it doesn't. No, it doesn't matter.
The bigger one got 'em or the smaller?
No, you just have to differentiate. One angle is 1 arc, the other one is 2 arcs. That's a good question. Okay, supplementary angles. That means these are angles who add up to be 180 degrees. Supplementary angles are angles that add up to be 180 degrees. 180 degrees is a straight line. This is called a straight angle. From here to here is 180 degrees. This is called a straight angle. It's called a straight angle. Okay, so supplementary angles are angles who add up to be 180. They don't have to be touching, they can be off to the side. You'll know they're supplementary because this one will be 100 and then or something that adds up to be 180. If that one's 100, then this one has to be 80, right? Sorry, that's kind of tiny. I just wrote 100 in one and 80 in the other, which means they add up to be 180 together. The most important kind that you will deal with in this term is a linear pair. This is the one you need to know. This one and vertical angles, but more so a linear pair because they will follow you forever. A linear pair are 2 angles that are adjacent, so they're touching. They have a common side, and they are supplementary, and they make a straight line. So this is an example of a linear pair. They make a line together, and they're beside each other. So I'm talking about this angle and this angle. These 2 lines together make a linear pair. That means together they make 180 degrees. Another way I like to show students is that they make what I call the horizon. Meaning if this is a straight line, I can draw like a sunset coming up. They make a straight line. Sometimes that's helpful for students, sometimes it's not. Okay, but together they make 180 degrees. Okay, let's do a quick, on the next page, we're going to do a quick inventory of types of angles. So you're going to have to flip back and forth. It says select all that apply. So in number 1, we have 1 and 2, angle 1 and 2. Someone raise your hand. What do you know about angle 1 and 2? What kind are they? Someone who haven't heard. Sharmini. Vertical. Was that a question or was that a confident answer? Confident answer. Okay. They are vertical, right? They are across from each other. We don't know anything else about them. We just know that they are vertical. If they are vertical, though, what does that mean about their measurements? Good, Caitlin. They're the same. Okay? All right, number 2, Monique. What do you know about angle 1 and angle 2 on number 2? What do you know about them? Angle 1 and angle 2. Are they beside each other? Is that a question? Okay. Are they beside each other? Yes. And that is called what? Flip back. They are adjacent if they are beside each other. Right? That's what that word means, adjacent, beside each other. Something else, though, guys. You can not go to sleep. We're working on 1 and 2. What else do we notice about these, Darius? Ooh, are they supplementary? Together, do they make 180? Shelly? Are they, do together just 1 and 2 make a line? Caitlin? Complementary. Why do you know they're complementary? Okay, I need you to listen. This is really big. Go ahead, Caitlin.
They equal 90.
Okay, so if we are looking at this, okay, over on this side is 90, right? And so isn't every line 180 degrees? Yes? Okay, so what's 180 minus 90? 90, which means over here has to be 90 as well. Go ahead and put this on your diagram. Make this 90 as well over here. So that means that 1 and 2 together have to make 90 degrees, so they also are complementary. A tricky one there. Okay, number 3, Tylea. What's something you know about number 3, about those 2 angles? Do they make an X? Are they across from one another on 1 and 2? No, so they're beside each other, right? They share this side. So what's it called if they're beside each other? Perfect. So they're adjacent. Okay. What else do we know, though, guys? John? They're supplementary because don't they make this 180 line, guys? Don't they make that line together, the 2 of them? So they're supplementary, but if they are also a linear pair, right, because they make a line together. So they're also a linear pair. Well, we're going to keep practicing. Okay, number 4. Donald Scaife. What do you know about number 4? I don't know. It's not an answer. Are they across from each other or are they beside each other? Okay, what's that word? That means beside each other. Good. Adjacent. Do we know anything about them making 90 degrees? For sure. They kind of look like they make 90, but we don't know because we don't have that box there. Okay, and they're not 180, so they can't be supplementary or a linear pair. So just adjacent on number 4. Good. Number 5. Braxton, what do you know about number 5? Excellent. Do you see that 1 and 2 are across from each other? So they're vertical. Okay, number 6. James? Okay, we'll get there. Before they're supplementary, what do we know? They're vertical. Okay, but then I want you to look at number 6 with me. I want you to look at number 6 with me. Make sure you mark the right thing. If this box right here is 90, how much is angle 1? 90, right? Because 2 together, if this side's 90, then this side has to be 90 because they make that line, right? Then what happens if I kind of spin my paper a little bit and I talk about this box and down here at angle 2? Isn't this also 90? Right? Okay, so if they're both 90 and I add them together, what's 90 plus 90? 180, which means these are also supplementary. They are not a linear pair because they're not beside each other. Right? They have to be beside each other to be a linear pair.
So
Yes.
wouldn't-